Hello and welcome to this explainer. Today, we are diving deep into the legal anatomy of the global e-waste trade. For those of you who might be preparing for an environmental law exam, or if you just want a masterclass on how international borders handle toxic tech, you are in the right place. We're going to conduct a comparative regulatory autopsy of exactly how electronic waste moves across the globe. And look, this won't just be a surface-level overview. We are going to meticulously dissect the exact legal instruments, the international conventions, and most importantly, the fatal loopholes that still allow illegal dumping to happen right under our noses. Okay, let's get into it.
Okay, let's dive into this. Think of this as your visual syllabus for mastering this topic. We'll start with the global e-waste crisis as our baseline, then look at the international rules with the Basel Convention framework. From there, we'll examine India's specific e-waste legal regime, uncover a massive definition loophole, look at the very real customs and enforcement challenges on the ground, and finally wrap up with a U.S. comparison and some actionable solutions.
Starting with Section 1, the global e-waste crisis and the massive problem at the border.
Now, we need to be clear right off the bat. This isn't just everyday trash. We're dealing with highly hazardous materials. We're talking lead, mercury, cadmium, and brominated flame retardants. The sheer volume of e-waste generated globally is absolutely staggering. And its movement across international borders, well, that's driven by a really complex interplay of simple economics and glaring regulatory loopholes. Developed nations are the primary generators, but a massive portion of this waste flows directly into developing nations like India. You might be wondering why. Well, it's the allure of cheaper processing costs and, frankly, lax environmental enforcement. This toxic flow directly feeds unregulated informal recycling sectors. And when these items are broken down using rudimentary extraction practices, it severely contaminates the soil, the water, and the air, all while posing grave health risks to the vulnerable workers processing it. That brings us to Section 2, the Basel Convention framework, which serves as the international standard. All right, if you are taking notes for an exam, absolutely highlight this. If there is one foundational concept to grasp here, it is prior informed consent, or the PIC procedure. Enshrined in Article 6 of the 1989 Basel Convention, you can think of PIC as the ultimate international permission slip. In plain English legalese, it mandates that you cannot simply ship hazardous waste across borders, period. Any movement requires explicit written consent from the importing state and even the transit states before that waste ever leaves the port of origin. Let's move along and see how this builds in practice. The PIC procedure acts as the crucial first line of defense, and it happens in 3 strict steps. Step 1, the exporting state absolutely must formally notify the competent authority of the importing or transit state, and they have to provide highly specific details about the waste's origin, the quantity, and how it's going to be disposed of. Step 2, the importing state evaluates this notification and has the absolute right to consent with certain conditions, or to outright refuse the shipment. Step 3, the movement is legally permitted only, and I literally mean only, after explicit written consent is fully secured from all parties. It's a strict procedural safeguard to prevent unwanted toxic dumping. Understanding the historical evolution of these controls is totally key to understanding the law today. So the Basel Convention was adopted in 1989 and entered into force in 1992. But, it quickly became apparent that merely requiring consent just wasn't enough to stop the exploitation. This realization led to the 1995 Ban Amendment, which outright prohibits OECD and EU countries from exporting hazardous waste to developing nations. Now, this critical amendment finally entered into force internationally in 2019. But I want to emphasize this last point, the 2024 e-waste amendments. This was a real game changer because it finally closed a long-standing gap. Under this new amendment, all e-waste, even non-hazardous e-waste, which is classified under the code Y49, is now officially subject to the strict PIC procedure. Let's transition to Section 3, India's e-waste legal regime. This is the domestic shield. Now, what's really interesting about this slide is how it perfectly contrasts the two halves of India's legal defense. This is a classic, highly retainable law exam comparison. On one side, we have the hazardous and other waste rules, or the HOM rules of 2016. Their primary focus? Border control. They act as the first line of defense by explicitly prohibiting the import of hazardous e-waste for disposal, specifically categorized under Schedule VI as A1180. The licensing here is governed by the Ministry of Environment, Forest, and Climate Change. On the other side of the coin, we have the e-waste management rules of 2022. Their focus shifts internally to domestic management and formalization, and this is primarily enforced by the Central Pollution Control Board through a very powerful mechanism known as extended producer responsibility.
Let's break down that 2022 mechanism a bit more, because extended producer responsibility, or EPR, is absolutely crucial. Under these newer EWM rules, the legal definition of a producer was critically broadened. It now includes anyone who imports electrical and electronic equipment, whether it is brand new or used. This means importers are legally compelled to obtain EPR authorization from the CCPB, basically forcing them to meet mandatory collection and recycling targets. It acts as a regulatory choke point. It ensures that if you bring electronics into the country, you are legally and financially on the hook for their environmentally sound management at the very end of their life cycle.
Moving right along to Section 4, the definition loophole. This is the fatal flaw in the system.
So the entire legal framework we literally just unpacked, it hinges on a single, incredibly fragile distinction. It's the ambiguity gap between used EE and end-of-life EE. Used equipment is legally intended for reuse or refurbishment. Under the foreign trade policy, it is simply classified as restricted, which means you only need a license to import it legally. Easy enough. On the other hand, end-of-life EE is considered obsolete, broken, hazardous waste. Under the HOMR rules, bringing it in for disposal is completely banned. The underlying problem here is practical application. Imagine being at a busy, congested port. Trying to objectively distinguish between a restricted but legal shipment of used goods and a banned shipment of hazardous waste is exceptionally difficult.
This ambiguity essentially creates a legal Trojan horse. This system operates on what we call the intent test. Because there are no mandatory functional tests at the border to prove an item actually turns on and works, the burden of proof relies almost entirely on the importer's stated intent. So illegal traders just disguise their shipments of obsolete, hazardous junk as restricted but perfectly legal used goods meant for refurbishment. They pass right through customs without raising any alarms. Once inside the country, the Trojan horse opens. The broken items are diverted straight into the cheap, unregulated, informal dismantling sector. The entire legal ban is completely bypassed by a simple paperwork misdeclaration. Crazy, right?
Let's look at how this plays out in Section 5, Customs and Enforcement Challenges. The frontline reality.
A law is only as strong as its enforcement mechanism, and at the ports, we are seeing massive operational failures. Let's run through these quickly. First is outright deception. E-waste is frequently misclassified under innocent-sounding harmonized system or HS codes like scrap metal or electronic parts. Second, a severe lack of technical infrastructure. Ports simply don't have the specialized X-ray scanners needed to detect hazardous heavy metals without physically opening every single container. Third, you have an entrenched domestic informal sector creating a massive, lucrative demand for this illegal waste. Fourth, agonizing interagency coordination delays between customs, the MOEF and CC, and the CPCB, which leads to severe port congestion. Fifth, because the legal detention procedures are so incredibly cumbersome and expensive to maintain, authorities are often pressured to just release suspicious consignments prematurely. And finally, the financial penalties under the Customs Act of 1962 and the FTDR Act of 1992, they offer incredibly weak deterrence compared to the massive profits being made by these criminal syndicates.
Which brings us to our final section, Section 6, U.S. Comparison and Solutions. Let's look at the comparative fix. So the crucial point here is the stark contrast between India and the United States when it comes to legal philosophy. India operates on a centralized federal framework, heavily relies on a near ban on hazardous imports, and has fully ratified the Basel Convention. The United States, however, operates on a fragmented patchwork of state-level laws alongside the Federal Resource Conservation and Recovery Act, or RCRA. Critically, the U.S. has absolutely no federal export ban on e-waste and has not ratified the Basel Ban Amendment. This legally allows them to continue exporting these materials. Instead of strict federal bans, they rely heavily on proposed but not yet enacted bills like the Secure E-Waste Export and Recycling Act, or SERA, to try and stem the flow.
Now, because the U.S. lacks that strong federal ban, they've actually innovated in a different direction using market-based mechanisms. The U.S. Environmental Protection Agency issues strict guidance on testing electronics, but the real drivers here are voluntary third-party certification schemes like eStewards and R2. These schemes are fascinating because they require rigorous, objective testing and verification of used equipment functionality before export is even permitted. Businesses are strongly incentivized to use only certified recyclers, creating a market-driven approach to responsible practices. And honestly, this objective testing standard is exactly what India's legal framework currently lacks at its borders.
So keeping all these legal frameworks, the fatal loopholes, and the operational failures in mind, it all boils down to one monumental question.
can India build a true circular economy to permanently close these loopholes?
The answer lies in a few very specific, actionable recommendations. First, we have to strengthen definitions by mandating objective functional testing, requiring third-party certification from the exporting country, and establishing a minimum residual lifespan for all imported used EEE. This would permanently close that intent loophole. Second, enhance border enforcement by deploying advanced non-intrusive scares and creating dedicated interagency e-waste task forces at key ports. Third, pursue aggressive international cooperation to share intelligence bilaterally, especially with major exporters like the U.S. And finally, incentivize domestic manufacturing of repairable electronics while supporting a truly robust formal recycling sector. By integrating strict standards with aggressive enforcement, these legal barriers can actually hold. But it leaves us with one final thought to ponder. As our global appetite for new electronics continues to accelerate at breakneck speed, will our international legal frameworks ever truly outpace the speed of our own consumption? Thank you so much for joining me for this explainer, and good luck with your studies.